up next, relate factors and multiples. So although factors and multiples are two different things, they are related, and we're going to see why in a bit. Let's go. Which set of numbers are shaded on the 100 chart? So it looks like 33, 66, and 99 are shaded on this. I hope you can see that. So we want to know, is it the factors of 33? Is it the multiples of 33? Is it the factors of 99? Or is it the multiples of 99? Yes, this is a 4th grade problem, friends. Let's start by again talking a touch about the difference between factors and multiples. 33 is, I think the only factors are 1, 3, 11, and 33, right? It can be 1 times 33, it can be 3 times 11, and that's it. That's all the factors in 33. So let's take a look at our chart here. Only one of these is in there, and that's 33. So these are the factors, and it looks like that's not the correct answer for this problem. So what are multiples of 33? Well, multiples is when you start either counting by, in this case, 33s, or when you start multiplying, right? A multiple is going to be usually bigger than the original number. So 33, is a multiple of 33. Then 66, because that's 33 times 2. Then 99, and that's looking familiar. That's looking like it's up there. So again, I want to highlight this one more time. I know I'm really going over this a lot, but I find that this can be very confusing for students and adults alike. Factors of 33 are 1, 3, 11, and 33. Those are the numbers that you can use multiplication to make 33. Multiples of 33 is when you start with 33 and then start multiplying it by 1 or 2 or 3 or 4 or 5. So that's the difference between factors and multiples. So with that in mind, we know that and there's only one answer. So we know that the multiples of 33 are in there. Nice. So again, this is less of a math problem and more of a reading and vocabulary problem. We know that 2 times 6 equals 12. I like that they provide that little bit of context just in case. Some students in 4th grade are still working on their times tables. Some folks in their 30s still work on their times tables from time to time. Some math teachers sometimes have a hard time with their times tables from time to time. So which of the following statements is also true? 6 is a factor of 2. Well, no, 6 would be a factor of 12, right? 6 is a factor, it's being multiplied, but the thing it's multiplying to make isn't 2, it's 12. So we say that 6 is a factor of 12, not 2. 12 is a multiple of 2. Yes, 2, 4, 6, 8, 10, 12. It is a multiple of 2. If I am counting by 2s, I will eventually hit 12. 12 is also a multiple of 6. It's the second one, right? 6 times 2 is 12. And those are our two answers. Laura tried to shade all the multiples of 12 on a 100 chart. And she got these. She got 1, 2, 3, 4, 6, and 12. What mistake did Laura make? Option A, she shaded 6 multiples of 12, but left out some. B, Laura did not make a mistake, always a possibility. C, Laura shaded 12, but multiples are always greater than the number. That's an interesting one. We'll come back to that one in a second. Or D, Laura shaded the factors instead of the multiples of 12. So looking at this, I would say that it looks like she shaded the factors instead of the multiples, right? 1 times 12 is 12, 2 times 6 is 12, and 3 times 4 is 12, right? These are the numbers that you use multiplication to make 12. They are the ingredients to make 12. So I think that that's what she did wrong. But I also want to take a look at this option C. It says Laura shaded 12, but multiples are always greater than the number. And that's so almost correct that I really want to highlight it. Okay? Multiples are always greater than or equal to the number. Right? 12 is a multiple of 12. It's 12 times 1. It's the first multiple of 12. If you are counting by 12s, 12 is the first one that you say. Every other multiple is going to be greater than 12. So it's so close to correct, but not quite. Our answer is D. What set of numbers are shaded on the 100 chart? Well, the fact that 1 is shaded automatically makes me think that these are probably factors. And looking at 53, I don't know for sure off the top of my head, but I think 53 might be a prime number, which would make sense. A prime number, which I have not said in this stream yet, is a number with exactly 2 factors. Which are 1 and itself. Seven is a prime number. There is nothing you can divide 7 by evenly except for 1 and 7. 7 divided by 1 is 7. 7 divided by 7 is 1. That's all you can do. So a prime number is a number that can only be divided by 1 and itself without remainder. As a quick side note, by the way, that does technically mean that the number 1 itself is not a prime number because it only has one thing it can divide by. I'm going to say that it is the factors of 53. It's definitely not the multiples of 53. And if it was the multiples of 1, it would be everything, right? Everything's a multiple of 1. So I think it's only the factors of 53. We know that 7 times 8 is 56. So which of the following statements are also true? 7 is a factor of 56, and 8 is a factor of 56. Those are the two things that you multiply together to make 56. Elijah tried to shade all the factors of 50 on the 100 chart. Wow, I can speak. Looks to me like he almost did it right. I think he just missed some. Okay, we're gonna get some options as to what mistake he made. Looking at this, 50, well, it can be divided by 1. So I'm gonna say factors of 50. It can be divided by 1, everything can. It's even, so it can be divided by 2. 5 is correct. It ends with a 0, so you can divide it by 10. 25 and 50. I think those are all of the numbers that you can use to multiply, all the whole numbers that you can use to multiply to make 50. So it looks to me like she got a good start. She just didn't quite get all of them. Let's see what our options are. Shaded the factors of 25 instead of the factors of 50. That makes sense. These are the factors of 25, 1, 5, and 25. Elijah shaded 3 numbers, but there are always an even number of factors. There is not always an even number of factors, so that's definitely wrong. Elijah shaded multiples instead of the factors of 50. He did not. So yeah, I'm going to say A, he shaded the factors of 25 instead of the factors of 50. All right, what do we have here? We have 1, 3, 5, 9, 15, and 45. If I want to know whether or not these are factors, there is a kind of a trick that you can use to figure it out. take the biggest one and the smallest one. Okay, so the biggest one is 45. The smallest one is 1. Yeah? Multiply them. We get what? 45. Same deal with the second biggest and the second smallest, which is 15 and 3. 15 times 3? 45. Definitely thinking that we've got factors here. And then the last two are 9 and 5. 9 times 5 is 45. What we have here is the factors of 45. If you have all of the factors and they are all arranged in order correctly, the first one times the last one should equal the product. The second and the second to last, the third and the third from last, they should all pair up nicely. So maybe that'll help you on a test someday. Who knows? Only all the factors of 45. If you had included the factors of 90, then 90 itself would be involved. And that is relating factors and multiples. Not bad, not bad.